Was it doing that before?
I just assumed you press record.
I did press record before. Okay, go ahead.
Go ahead. So this is a very easy to see, very clear diagram that I found, and it's again about what I was talking about the life cycle where you design the building. Oh, again, I didn't touch it. How do I go back?
Just use the arrows on the keyboard.
Okay, sorry. So about the life cycle of the building, where every phase has to be considering sustainability. When you design the building, you have energy issues and water conservation that you have to take into account. And then during the construction, the operation and maintenance and the demolition and disposal of the building as well. And everything has to, everything is related to what materials and systems you use, and how do you manage the waste that you produce when you are building a building. And then everybody that is involved in those stages. So the 6 principles of sustainable architecture, and I'm going to tell you all of them, but we are going to concentrate on the 3 first. It's optimize the potential of the location, which is when you position your building on the field, what is the best way to do it sustainably. And then optimize the use of energy, and that is from the design point of view. When you are designing your building, how to use as much as possible passive systems on the design, so you have to use less mechanical systems, which are the ones that use energy, obviously. And protect and preserve the water. That is a very important resource we have to take care of. And then use products that take care of the environment. That's related to every material you are going to use on that design. Improve the indoor quality. That is always, we always hear that people have more allergies or respiratory problems, and that is also related to what we put inside the buildings, the materials we use. It's actually called VOC, organic volatile compounds, things that are on materials that can affect your health. And then the optimization of the operation and maintenance of the building. Again, I said that after the building, the design and building of a house, you need to optimize how you use that house. Okay? So I said it. Okay. So passive design guidelines for our city. The most important info to begin designing a building is the local weather. You need to know the weather on the site that you're going to work. It's very, very important. And there are diagrams that help you to do that if you want to get deeper, but I think that I just thought about just telling you what's the type of weather we have, although I know you probably know it, but it's to be more precise, because that will determine what are the passive systems that we are going to use on the design of our building. So for Austin, we know it's really hot. It's a very hot climate. We have most of the months that we will need cooling instead of heating. And actually 65% of the time we require cooling over heating. To keep the comfort, there's the comfort zone, which is the time of the year or the temperature that you need to feel comfortable, like we are now. It's about 74 degrees. And we don't have that much here. We usually have from, I would say, May to now to September, 84 degrees average here in Austin. Average, okay? And then So we will need to keep that comfort. We need to we need to use induced ventilation and artificial cooling actually. So because it's a very hot place, we will need we will need energy to supply our mechanical system, which is the air conditioning. But that doesn't mean that we cannot use some passive design. So the design conclusion is that there is an ample opportunity for passive winter space heating. Even if it's just a few months, we can use that resource, which is the sun, to help us to heat our houses. But we need to be very careful how we take advantage of the sun, because we can have overheating. So we need to size the windows properly. We need to give the surface of glazing needs to be very, very well calculated, and we need to also shade those windows during summer, spring, and part of the fall. Okay. Okay, so the orientation and sun exposure. This is valid for northern hemisphere because when you go to the southern hemisphere, the sun actually walks through the north instead of the south. You know that? Depending on where you were in the world, the sun path changes. So we are here in the northern hemisphere, and the sun makes their path through the day on the south area. It changes the angle during the year, like in winter is lower and in summer is higher, but it makes a curve through the south. So the south facade receives the most sun radiation during the whole day, but it's the easiest facade or the easiest face that you can control, and that is with overhangs or awnings. The west and east facades receive much deeper sun, and it's in a lower angle, but it's harder to control with overhang, because when you have the sun that low, there's no overhang that can stop it. You will need some vertical object to do it, like a tree or a wall, something that is there on a vertical position. So you can also use some things, blades, screens, or tricks. But in this drawing that I put here, it's easy to see the apparent sun path in winter and summer. So in winter, the sun is lower, so it can have access to the interior to use it for passive heating. And in summer, you need to design either awnings or overhangs to protect the glazing or the window to have direct sun on it. Because once the sun hits the glaze, it's hard to control. Even if you put double glazing or screens, it's still very hard to do. Obviously, it's always smart to use what we have on the site. So if you have trees, it's very smart to use them, obviously, because they will help us to keep shading. And like here on this drawing that I put, these are trees that don't lose their leaves. And in this particular project, they are on the side of the predominant winds in winter, so they are also helping you to stop the cold winds in winter. So it's protecting the house from getting too cold. And then here, the ones that are on the west and on the east, remember that I said west and east are very hard to control because the sun is so low. So a tree is ideal for covering the windows that are there. And obviously, if you put something here on the north, in the south, it will have to be trees that lose their leaves during the winter, so you can have access to sun on the winter months. So some passive cooling strategies, it's very, years ago, there were no air conditioning or any mechanical system. So the people needed to keep fresh, or their houses needed to be comfortable without any mechanical system. So it's smart to see how they accomplish that comfort without any mechanical system. These are just examples. For example, this is in Egypt, and how they use these round shapes and all together, so they shade each other, and in that way they protect from the sun, from the excessive sun exposure. And they also have little windows that, the less windows, the less sun penetration. So it's actually better to keep those houses fresh on that way. And they're also using mud, or clay, which is a very very resistant to the pass of the heat. So it's very smart. If you see Asian cities, it's smart how to see how they keep their, even if this is a hot climate, but if you go to a cold climate, you will see the same, the adaptation to the climate without the use of mechanical system. And that is called vernacular architecture. And it's very, very interesting to see. So this is how you can take advantage of the roof shape and inclination to, in this case in Austin, to have less solar radiation influence. For example, if you have, every 10 degrees that you lift your roof, you will have 10 to 15% less heat from solar radiation. It's just because of the angle, how the sun is hitting, you will get less heat. The round roofs are the ideal because there's just one time that the sun is hitting on the same angle, so that will help also, and actually more, to avoid that excessive heat. Again, the same is with the walls. Everything that is curved, it helps to avoid that much overheating. Here I put another graphic. So like if you just do a roof, like a slope roof like this, you just cut it in half, and then in 4 shapes. Then the one that are curved, like these elongated domes, and the best will be a dome. Okay. Also, the use of your geography, where you are, and the mass. So the thicker, the heavier the material, the better for avoiding heat, because the heat is going to spend more time traveling through that wall or through that material to get inside. The ideal thing is that during the day, you leave that wall or that material to start absorbing heat, and when the night comes and the temperatures get lower, then the path of the heat is vice versa, so it goes back. It goes to the outside. The heat always travels to the more heated area to the cooler area. So during the day, it will travel towards the inside of the house. At night, it will go the other direction. So the idea is that you make it thicker enough for the heat never to get inside the interior of the house. This is an example of, have you ever been here in Mesa Verde, Colorado?
I have.
So this is also an ancient culture that have used what they have around for their comfort. They use stone, which is very thick and heavy, so it protects them from the heat. And they also have these cliffs that actually work as an awning. So during the winter, they have sun access, but during the hotter time of the years, that awning or that protrusion of the cliffs will protect them from getting overheated. And they use very small windows. If you can see to avoid also the sun. Another very important thing is the insulation. So if we don't have a very thick wall, we will need to add insulation, which is every material that can retard the path of the heat through that wall or through that roof. Okay? So there are a lot of different insulations that you can use. How do we design our interior spaces to be, in a smart way to get advantage of all this that we've been talking about? We said that the south is the path of the sun during the day, so we want the living areas to be closer to that, because we have to trade between the light and the heat. We all want to have good views and to have sun in our houses, but we have to be smart how we position those spaces within that house. So the living areas are the one that you want more exposure to light, but also we have the opportunity to control them easily with overhangs, or obviously you have to design those overhangs to be really useful. So there is also calculation, there are diagrams that you can use to do that. But the idea is that you have to let the sun in only on cold time, the cold weather. So you have to design your overhang to be long enough to protect that facade, that glazing that goes towards the south during the hot time. It's always good to have, here is the east, so to have sun during the morning in the kitchen or dining. You can also have the dining on this side. And then bedrooms, you can put it either way. It's just a matter of how you control the heat during the afternoon or in the morning if you need. And then the north area is going to be cooler in winter. So those are buffer spaces, closets, stairs, hallways, garages. But the living areas need to be, using the south facade. So again, talking about the windows, for this area, we need to do a very smart distribution of what we are going to expose to that facade, to that south facade. So the sizing is very important. And what are we going to put on the sides, on west and east? Not very huge openings. So we cannot have the luxury to have like a big window to the west. That's going to be a big mistake. You're going to have very heat space there, very hot space there. The tightness of those windows are also very important. So we have to, get very good windows with double glazing here in Austin. You also need low-E. You also need a low-E type of window. And also the shading, as I was telling you, this doesn't have a lot of projection on the windows, but I have here a little bit. I don't know if it's worth it. It's just a guy explaining all that very easily. If I click here.
Yeah, sure.
Yeah.
Did you not click to it?
No, I don't know. But I did it with a. Let me see. No, it's not working as a link, I think. No. It's okay.
Okay.
So again, I was telling you about the how tight. This is very important because all the infiltration we can have, cold air in winter. To have a very good window, it's important, and also, tight. The whole house needs to be tight, so we can keep the heat if we need, or the cool if we need in the summertime. Again, here all that is showing that there is insulation all around the house. It's either insulation or again high mass, so concrete or stone. That's probably when I was trying to click the link. I guess. Again, it's showing you here how to design your awnings or your overhangs in order to avoid summer heat and to let the sun get into the house in winter. So that's window design, and it's not just tossing